Today's job, now finished, is implementing Bayesian trait assignment of some query OTU on a large phylogeny. Now, Bayesian trait modeling, I've been doing this quite a lot last couple of years. I've done this for bees, for actually two different projects for bees. One is predicting traits for some OTU. Second, I've been predicting traits for internal nodes. Two different things. One tips, one internal nodes. I think I've also done this for hoverflies. But for this project we're working on today, this is for Lepidoptera, and we're using it for profiling caterpillar CO1 barcodes at Beth China. So phylogeny is finished, process the OTU roughly, and just now implementing a basic trait assignment, and the first trait assignment, so trait predictions for OTU are just finished. So made a new folder, copied in the phylogeny. It's a phylogeny of about 6,500 references from bold, and also placed the OTU on there. Just copy that into a working folder. Covered in the trait data. So this trait data is for a subset. It's for the butterflies, where there's a good trait database available. So copy that in. Let's get a list of the terminals in the tree which I need. Now for base traits it requires nexus format, but not any old nexus format. It has to be very specific. And I know this because I use Fig Tree and Archaeopteryx for viewing trees, and well, this morning I tried saving the XML output as a nexus file in both those software, and the base traits wouldn't accept either of them. I did that because this didn't work immediately. So this is base traits wrap, which you can see I've been using for a while now. First started working on base traits when I was in Czech Republic a long time ago. Still using the same script for. This wasn't working at the moment. I just use it for actually converting format the nexus format used by base traits, which, as I say, suggests is a bit specific. But it wasn't working on the OTU. I needed to change just one of these. So the OTU labels on the phylogeny seem to be a bit shorter than expected by this regular expression. So this used to be 2. I just had to change this to 1. That works okay. Converted to nexus format. Process the trait data. Just opted to use a bit of Perl code on the, not specifically the script itself, just write it in like this. So open the butterfly trait data for a single trait, volatinism. Just store all those into a single string. Open list of terminals. So the OTU are not included in the trait data. So the OTU are the queries for the trait modeling. So that those need added. So writing both of these. And then format of base traits is, you can see here, this is the input file I need. Now got 2 of them. You can see looks similar at first. So we have, these are the references, we have the gaps where there's no trait data available, and then we have the state where available. But if we go down to the OTU, now of course for the queries we don't know what they are. That's what we're trying to predict, and this is where the difference is between the two files. So you put the question mark where you're trying to predict. So the first file is to create the model, and then second file uses a model, and then It's just defining what you're trying to do, which is trying to predict the states for these IDs of the terminal, which are the queries. So then run base traits. This is just a long thing. Just makes the commands file for base traits. Makes 2 of them because you run base traits twice. First to create the model and then do the prediction, and then a script to parse the output of base traits, which is here. So we have well, a couple. So here are the queries. So these are again OTU of caterpillars, and we've predicted. So here's a probability of 3 states for 1 generation per year, 2 generations per year, or multiple generations per year, and where we have high numbers, let's have a look for about 10, and probability of 1, so 11, 12, 13, 14, 15. So for this trait we probably have about 25 successful trait assignments for the 300 or so query OTU. So that's a bit low, and hopefully but this very much depends on the level of conservatism. So this is the first trait I've tried. So I've got a bunch of other traits, and hopefully some of those other ones will be more conserved, and we will have a higher rate of trait assignment. But for now, that's job done. Next thing I need to do is I'll just plot this, which can be a bit awkward thing to plot, a huge thing with all these predictions on there, so it will take a while. I'll probably do that tomorrow, but for now we have predicted states for a single trait for query caterpillars on a large reference phylogeny of Lepidoptera.